Hello, welcome back to Brand Sushi LIVENODING. In this episode, we're gonna talk about topic matrix. The matrix, like in terms of matrix transformations, both in Sverchok and also in animation nodes. So it's gonna be kind of interesting. So let's just get started. So whenever I think about the matrix, normally the easiest and fastest way to show it is using viewer draw. So by default, it's showing nothing. But here, if you have something like a box, and then you pipe in the polygon data, whether it's edges or polygon, you can then create this matrix transform. And you can see here, matrix transform is just like typical transformations. You have locations, scale, rotations. So that's representing the position and the scale, of course. And the rotation is actually, you can see 0, 0, 1 and angle. So if you're guessing, this is the axis 0, 0, 1, and normally there's actually an axis node here. So this guy right here, let's say you want 0, 0, 1, you just do it like that, and now you're rotating at 0, 0, 1 axis. And then if you bake it out, you're gonna get an object with that transformation. So that's the basic, right? Similar case, you can have like a matrix interpolations, and then you can have two transform, and let's say you have Suzanne, and you can do the same thing. Let's say we want to rotate Suzanne in the 0, 0, 1 axis, actually 1, 0, 0. You can do it this way, so it's kind of interpolating between the two. If you want to do it to many Suzanne at the same time, then you need to provide a lot of Suzanne, so you need a lot of matrix. So let's show it really quick. You can use factor P. Oops, factor P. And let's say you have 3 by 3 and 1. Plug this into the locations, so you have now many Suzanne head, and you can still do interpolations. But because we have a lot of value here, 9 matrix and 1 matrix here, it's still Sverchok node still interpolates between the two. So that's interesting. Let's try doing the same thing using animation nodes. So delete everything. With animation nodes, normally you already have an object in the 3D view. So this is AN matrix. And the fastest and easiest way to understand or using matrix is to use matrix output. So if you select Suzanne and you need to provide matrix data, you use compose matrix, and you are now able to work with Suzanne. So translation, rotation, scale. A more interesting way is actually to use instancer. So this is the matrix output. This is gonna be Suzanne. So we want to have a lot of Suzanne, so we're gonna create distribute matrices. So different naming, similar concept, very similar. So the matrices, this is like multiple matrices being generated, grid 3 by 3, so we have 9. So what I'll do is to plug this into the matrix here, and then the objects goes into the objects. Now we have 9 Suzanne. This is the original master Suzanne being instanced over this matrix. So yeah, very, very similar. What's really cool, of course, you can do something like offset matrices. So this is like, the setup is really simple, but you can do really powerful things because now you have control over each and every Susan head, like this. So offset matrices, kind of like strange or maybe scary. Offset is basically, let's say you have transform, and you, by offsetting the matrix, you kind of like pushing it from the original position. Sometimes you're pushing it, or sometimes you scale it, or sometimes you rotate it. It's not exactly interpolations, but it's gonna help you. It's kind of doing interpolations for you for free, and you control that using the fall off. So this transformation is gonna be the final, let's say, the final result, or it's kind of like pushing it. See, originally the scale is 1, so you change it to 0. This is what you get. If you change it to rotate 19 in X, rotate 180, you're gonna rotate it and scale it at the same time. So similar. In this case, maybe we need to also put this over here. So this is scaling. With Sverchok, I think a lot of things are vectorized, so you can plug a lot of data at the same time. Although animation nodes seems to be doing that as well. So it's especially animation nodes version 2. So with this fall off, it's already pretty cool, but if you look at fall off nodes, you have plenty of nodes dealing with the fall off itself. So the fall off, you can think of it like a value between 0 and 1. So between 0 and 1 is kind of like interpolating between the two. But if you use like any of these, it's gonna give a lot of control. Let's start with the point distance, for example. So I just plug it in into the fall off. There is this origin, and this is kind of giving you can see the origin at 0, 0, 0. It's affecting Susan that's near that point. You can control the size. Let's see, instead of rotating 180, let's just scale it. Let's make Susan like 20 by 20, so a lot of Susan. Just like that. If you want to get rid of this all these lines, you just clear the parenting, display, disable relationship lines. So now we can see the effects of this point distance fall off and Susan head. I think rotation is really cool. You can do the flip animation this way as well, actually. So point distance. Let's look at others like directional. You can do it direction, like if you imagine there's a line here, it's gonna do it to the left and to the right. So you can see there's a line. It's kind of like a wave, almost like a wave. If you want to do a wave, you can push it up in the z-axis, for example. So direction is 100, 100 is the x. Okay, you can control the size. So you have nice wave there. So point, distance, line, and you have a lot of other fall off as well. I think most of them are easy to understand. Some of them a little bit tricky. Object controller can be useful. So let's say we're using object controller. Let's use icosphere. So now this guy should be controlling the offset. You can even scale your objects, and it reflects. Let's turn this into wire. Let's push this up a little bit more. So okay, offset, fall off width. So it's really handy. I kind of wish Sverchok have all these, but maybe they have already, but not as clear. And you can also mix fall off, I think. So mix fall off. That's really powerful. Use it with wiggle. Wiggle is like it's not a random value. It's a value that's based on the noise. So this will give you a little bit of noise. So whatever, see, let's reduce the amplitude a little bit. So this guy is within the boundary of the objects. It's simply being pushed up, while the rest of them is controlled by the wiggle. It's simple, but it's also really powerful. And if you use this for the first time, maybe it's kind of complicated as well. It's kind of scary. It's scary because you can do all this complicated stuff very easily. That's why. So now we have 900 Susan head. There's max, there's multiply. Okay, that's multiply. That's really interesting. Imagine if it's actually will be a lot easier if we can see this fall off as a texture. Maybe that's something that I'll try to do using Sverchok and animation node. So Sverchok can kind of visualize what's going on here. If you imagine the fall off is like 0 and 1, 0 is black, 1 is value of white, you can perhaps see this as a texture. So Susan head is a bit heavy, but it's really fast. Animation node is really fast. I don't know how it works, but I just replace it with a plane now. Should be even faster now with the plane. You can see the effects there. Multiply, maybe. So pretty cool. Stop this. So with follow, which one is the one I have never used? Sound is pretty clear. You can have sound, and then sound have different value. If I'm not wrong, the fall off translation, you can actually give multiple values. You can plug here or fall off. Let's say random number. This is a multiple value. Plug it into the fall off, so you can see as I increase the number, I can have this value that I can even kind of go more, like beyond the limit of 0 and 1. So that's really powerful. Now it's like totally random. Excuse me. And then, but this is where you want to use like mix fall off, and you want more control with min or max. So that's the effects of min. That's the effect of max. Whatever value between min or max is gonna get clamped. There's also add and multiply. Multiply by 0 is gonna be all 0, 0, 0. So that's kind of controlling the weighting. Yeah, we can think of it the fall off like a weight actually. So much easier. So since I've been making a lot of videos, like over 1,000 videos, it's getting easier to understand some of these. Some of this used to be really abstract, and in the past I was actually always avoiding the matrices and only using the object transform output, which is this one is also kind of like the matrix. But in the past I've been always thinking in the term of location, rotation, scale. It's like 3 value. It's very easy. These days, think of it like the matrix, and it's really powerful, especially when you can mix the matrices or things like that. Mixed matrices is like matrix interpolations also. So a lot of nodes are really similar between Sverchok and animation nodes. With animation nodes, you kind of working always with actual objects in the scene, and each object is like a real object. In Sverchok, each object is still until you bake it, it's become real objects. Sometimes you can also like join the objects, so you're dealing with a single objects but many separate objects. That's really powerful in itself as well. So at some point I will combine animation nodes and Sverchok workflow. So that's really powerful, I guess. Okay, so I guess that's pretty much it for now. It's basically a video about matrices, matrix, object matrix, and then how you can easily offset it in animation nodes. With Sverchok, it's kind of like unusual. It's different, but also similar. So you can actually do something like this and then easily randomize the rotations, for example. Randomizing vertices. Yeah, so that's Sverchok and that's animation nodes. All right, thanks again for tuning in, and I'll see you next time. Thank you. Bye.